play basketball. I also used to be in the circus before I turned to mental activities. And we'll see if my circus skills come back to me or don't come back to me. But here's the history of science in 10 chaotic minutes from the year 0 to the year, well, we'll go up to the year 3000, unless I fall off the stage before that point. In the beginning, there was chaos and a big bang. And out of that chaos emerged order, which the ancients noticed. And the ancients, particularly the Greeks, decided that the heavens were perfect circles. The Greek Aristotle said that the heavens were crystalline spheres. The earth was at the center of the universe, and everything, including the sun, rotated around it on beautiful singing crystalline orbs, with man at the center. And here on earth, Aristotle said there was only one kind of motion, which was straight up and down. The heavens were perfect in circles, and in the earth, things only moved straight up and down. They only moved side to side if there was a mover, and that was called unnatural motion. And the world stayed in the history of science for almost 2,000 years inside Aristotle's 300 BC explanation of the universe, until the scientific revolution came about. And it came about not through technology and not through broad science, but first through tinkerers. An Italian named Tartaglia began looking at motion on Earth and noticed that cannonballs that he wanted to aim accurately went in arcs. Oh, and sometimes misfired. So there was curved motion on Earth. Was Aristotle wrong about other things? Another Italian, Benedetti, not Galileo, then tested Aristotle's belief that straight up and down motion, that heavier objects fell faster. Not Galileo, but Benedetti then dropped objects in Florence off the tower. And he dropped them continuously. And notice that Aristotle was wrong, that everything fell with the same accelerated motion. This was in the 1400s. And then in 1500, a beginning of a scientific breakthrough, a new theory. Copernicus turned around the Aristotelian world, said perhaps the circles of the heavens are not going around the earth, but the other way around, they're going around the sun. And a purely mental revolution took place. The same evidence that had always been there, circles in the heavens, switched around through a pure idea. Maybe you could just turn the idea around. And the Copernican system said that maybe motion went around the sun. This was not widely accepted until two men, Tycho Brahe and a Dane, without a telescope, the last great non-telescopic scientist, spent his entire life looking straight up at the motion of the heavens. In fact, there's a statue of him on the island of Vane in Denmark, and he's in this position. That's all he did every night for 40 years, observing all the motion of the heavens. Whoa! And he decided the heavens were dangerous. And he decided that the heavens were not moving in a circle, and certainly not moving in a circle around the sun. And when a comet shot through the motion of the heavens, he saw there couldn't be crystalline spheres. Following Brahe, Galileo built a telescope, 1609, and looked through it. And noticed not only that the motion was Copernican, but that the heavens were not crystalline orbs, that the moon had mountains on it and imperfections on it. And that Jupiter, as Aristotle said was impossible, had satellites going around it, had its own moons. So clearly the Earth was not the center of all motion. Unfortunately for Galileo and for my old body, the church opposed the Copernican system. So Galileo was handcuffed. Oh, that's really good. He was threatened by the church with torture unless he said that everything moved around the earth. So Galileo retreated and said the Copernican system was not correct. So science moved north into Protestant lands. First into Germany, where Johannes Kepler, a student of Brahe, figured out what the motion in Brahe's notes was. That the planets were not going in circles, that they were going in ellipses. He didn't know why they were going in ellipses, but he did the math to show that they were going in ellipses around the sun. The man who put this all together was a scientist also in a Protestant country, which was Newton, and showed through the universal law of gravity that motion was the same high to low, and that the rotations in the heavens could be understood mathematically. Different pace rotations were all the same gravitational pull, and his complicated new calculus showed how circles could go around circles, motions could speed up and slow down, and the scientific revolution was not complete because Newton also formed the Royal Society. And this was actually probably the most important scientific breakthrough, what you're all engaged in. A theory, a system of how scientists are supposed to work. Scientists had been put in jail for religious ideas. Scientists had published their ideas secretly in anagrams. They had not communicated with each other in societies, in universal meetings. They hadn't published their ideas, but the Royal Society, founded in 1660, that Newton helped put forward, taught scientists how scientists are supposed to behave. First of all, find out who gets credit for an idea. Don't grab somebody else's idea and claim it as your own. And don't grab everybody's ideas and claim it as your own. Also, don't go behind people's back. Don't steal their research. Don't hide your results. Publish them universally so that everybody can see them. More important than that, make sure that you remember what you talked about. Go behind backs. Grab. Explain what to do. Use your hands, use your head, spin around. Oh yeah. Most important of all, show your research. Don't just fake your results. And then, when you have a community of scientists, you can all use your heads together. Oh, we use our heads better than that. Keep your chins up. Fight the authorities. Be suspicious of people who come up with weird theories or weird new ways of doing things. Take turns being on top. Give credit to everybody. As important, bounce new ideas around. Bounce them off your colleagues. Test them with your colleagues. Kick around good new ideas. Thank you. Give away prizes so that people can spin around. Be congratulated. Kick new things up in the air. And pick bows. By 1800, the scientific revolution was complete, and since we've had those systems of science and meetings of science like this, science has become infinitely more complicated. The instruments are larger, more flashy, harder to understand. Their motion makes a whole lot less sense, and science moves incredibly fast. It's changing constantly. In the 19th century, the structure of the atom comes about, and ever since then it's been split and chopped up into subatomic particles of protons, neutrons, electrons, and now quarks. Science is dangerous because that splitting of the atom led to disasters like the nuclear bomb. Science has also gotten tremendously faster in its production of knowledge, and there are more and more scientists producing more and more ideas. It's also gotten complicated. It's spinning out of control. It's coming up with bigger and bigger ideas. Will technology survive? Will science survive? No! 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 Yes, say it.